Suppose two gas-filled balloons are hovering by lifting a mass m as in the diagram, are having equal charges plus q each. How much should be the amount of charge on each balloon? So we have to find the value of q in some other means. Use the hints specified regarding the geometry of the diagram. The hints are: angle between threads connected to the balloons is 2 theta. The length of those threads L each. If I am able to draw a line like this, this one, yeah. So this is a line corresponding to this knot and perpendicular like this, it is vertical. So the complete angle between this thread and this thread is 2 theta. So therefore this angle must be theta and this angle must also be theta. However, the length of the thread is at L each, and we are assuming the size of the balloon is negligible. Okay, so size of the balloon is negligible. So if you are thinking like this, then definitely we can solve it easily. See, this weight, the mass of this weight is acting downward, which is balanced by something which is acting in upward direction. This is nothing but the tensions in these two threads. How actually the tensions are? Tensions in the ropes are like this. So this is T and this is T. The tensions are like this. That means at this knot, how I can write? So this is the weight which is acting downward, which is at mg, and upward should be, see what? It should be the component of this T and this T, right? So two forces should act upward, the components of each tension, that is T cos theta on this side and T cos theta on this side. So that means 2T cos theta. 2T cos theta is acting in upward direction and downward is mg. So now to balance, okay, to balance what we must have, which is 2T cos theta must be is equals mg. Otherwise, I can say T is equals mg divided by 2 cos theta. So this much will be the tension which is acting in each thread. Okay, so we got something tension. So now we have to think for the forces between these two. Okay, for that, what I have to assume is, see, here is the balloon with charge plus q, and here is another balloon with charge plus q. So how much should be the distance between them? This matters. So for that we are using the clue, that is the length of the thread. Okay, so length of the thread like this. If we do like this, this much, I simply say it by means of this drawing. Okay, so this much as well as this line. Okay, so those two lines will indicate, when I take the component of this length along this line, so which will be L sin theta and L sin theta. So therefore, the complete distance between two balloons must be 2L sin theta, right? So the complete length between the charges, that means balloons, is 2L sin theta. From Coulomb's law, what we can write, the force between the two charges, point charges, is given by 1 by 4 pi epsilon O, right? So Q1 Q2 divided by R square. This is our formula. And what we can do now is F is equals to the force between the two charges, whether on this side or on this side. It doesn't matter now because we are simply finding the magnitude. So this is 1 by 4 pi epsilon O into, so the two charges are same, that means Q square which is given, so it should be capital Q, which is said in the question. Okay, so Q square divided by, so what should be R square? R square is nothing but length, that is distance between the two point charges, that is 2L sine theta. This becomes 4L square sine square theta. This will be the force between the two charges. Now you have to think further. We are having tension and we are having the force. Okay, so be careful. If I say one balloon is here, okay, the tension is acting downward like this, as seen from the balloon, it is T. At the force of electrostatic charges between the balloons, that will be F, that is acting in this direction. So what we actually know, we know the angle made by the balloon, I mean thread, with the vertical, which is theta. Otherwise, theta can be written here. Now be careful, the tension is acting here. Okay, so this is tension. So whose component can be taken along this line, that will be T sine theta. Right, T sine theta is acting in this direction. To balance, what we must do is, it is F is equals T sine theta. How much is F? F is 1 by 4 pi epsilon O into Q square divided by 4 L square, okay, which is here, L square into sine square theta. So that is equals T. T is mg divided by 2 cos theta into sine theta. Right. So what actually we need? We need how much should be the charge on each balloon. That means Q. So to solve Q, what we have to do is, we have to take everything which is on this side except Q to the right hand side. That means Q square should be is equals. So when I bring all these things on this side, this should be 16 divided by 2, which is 8 by epsilon O, right, L square, and mg, I should not forget mg, and this sine square and sine, so it becomes sine cube theta whole divided by cos theta, whole divided by cos theta. This will be Q square. So if you want Q, definitely it is 8 pi epsilon O L square mg into sine cube theta and whole divided by cos theta under root. This will be the answer. Otherwise, you can rewrite this as, it is a, 2, inside this we get 2 pi epsilon O mg sin theta divided by cos theta should be taken under root into L sin theta. This much we can write. Okay, this is also true. One more thing we can write further, that is Q is equals, right, Q is equals 2L sin theta, and in the bracket it is 2 pi epsilon O mg tan theta under root. So this is one of the result for such kind of situations. This will be the force, I mean charge, on each balloon. in this situation, which is Z for us.